Okay, 3.4 homework. We're on page 243. Oops, that didn't work. Page 243, we're going to look at number 39 first here. So number 39, we're talking about a track. And it says it's got a rectangle and then two semicircles on the side. So this obviously doesn't actually go to the middle. It's just the outside piece there. Okay, so our track goes, let me just get rid of that extra stuff there. We're actually just looking at that piece that goes around the outside, right? That makes sense to everybody? There we go, good enough. Okay, but in order to do this, we're going to need like the radius of that semicircle piece there. So I think with other people when I was helping them with this, we drew this in here and we called that like either X or Y. I think I called it X with most people. So let's call that X, and then we'll call this length from here to here Y. Okay, just for consistency's sake. And if you used other variables, it's fine. So what's my radius equal to? Half of X or X over 2, however you want to think about it here, same thing. Okay, now it tells me in the problem for 39, an indoor physical fitness room consists of a rectangular region with a semicircle on each end, so we got that. The perimeter is to be a 200-meter running track. So the perimeter is 200.
So 2x plus 2y?
Nope, because the perimeter would go around, all the way around the outside here, right? The perimeter wouldn't be the x, y, x, y. It would be x and then around this semicircle, sorry, y, and then y and around this semicircle. So 200 is going to be 2y. But how do I find the distance around the corners here, the outsides here? Isn't that going to end up adding up to be the circumference of that circle?
No.
Okay, so the circumference of a circle is 2 pi r. And instead of r, what am I going to put in that spot?
X?
2 pi, not x, but x over
X over
2. And the 2's cancel, so my circumference is just
pi
pi x.
x.
So this is just going to become plus pi x. So is this my primary or secondary? Secondary. Okay, then my primary equation, it's telling me I want to make the area as large as possible. So I'm trying to maximize area here. So to find the area of something like that, I'm going to have the area of this rectangle plus the area of the two semicircles, or the area of one circle, right? So my area, what's the area of the rectangle? X times y. And what's the area of a circle? Pi r squared. And instead of r squared, what am I going to put in that spot? X over 2 squared. So, and then here I'm going to solve this for y to plug into there. Okay, so I have area is x times y plus pi over 4. That's going to be the 2 squared x squared. I just pulled the number piece out front of there. And then here we can solve for x or y. I'm going to solve for y so I don't have so much to plug in. So if I solve my secondary equation for y equals, I would subtract the pi x over and divide by 2. So I have 200 minus pi x over 2. So any questions on that? And then we go ahead and we plug that into this spot. Does this look right so far? Justin, is this what you had so far, or did you mess something up there? Okay. So does anyone have any questions up to that point? Okay, then I go ahead and I plug that into here, and then what do I do with it? Take the derivative, find whether the critical points are maxes or mins, and remember we're trying to maximize the area. Okay, so try to find the critical point that gives you a maximum, and then make sure you answer the question. All right, so I'll give you a couple minutes to finish that. We'll see if we get stuck anywhere. And then we'll look at 41 here. 41 is a beam strength. It says a wooden beam has a rectangular cross section of height h and width w, so the figure is there and it's in your book as well. The strength of the beam is directly proportional to its width and the square of its height. I know it gives you this, but you should be able to write the equation even without it giving it to you. So it says the strength is equal to, or is directly proportional to its width, which would be w, and the square of its height, which would be h squared. And then you have a constant proportionality, which in some books is a and in some books is k. So k is a constant here, okay? Now it says here, hint, s equals k h squared w, same thing as what we have. K is greater than 0 is the proportionality constant. Okay, now it's asking, what are the dimensions of the strongest beam? So what are we trying to do with the strength? If we want the strongest beam, are we trying to maximize or minimize? Maximize this, right? So I need a secondary equation because right now I have how many variables on the right side? 2, because k is a constant. So just think of it as a number. So we have 2 variables right now, right? So the other part they give us, they say it's a round log of diameter 24 inches. So this would be the 24 here. So what can I do with my WH and 24 in order to come up with my secondary equation? Yeah, Pythagorean. So my secondary, h squared equal, or h squared plus w squared equals 24 squared.
Can we just move the squared over and try to make it equal to that?
I'm just going to, leave the h squared alone and subtract the w squared over. And then can I put this stuff here in for h squared rather than solving for h? So my strength is going to be k w and then 24 squared minus w squared. Now remember, k is a constant, so when we take the derivative of this, we just treat it like a number. Okay. Now 24 squared, if you want to multiply it out, you can. If you want to just leave it like this, we can. Does anyone know what 24 squared is? What's it come to? 576. Okay, so let's just throw it in there. So this would be 576. All right, now I'm going to distribute this kW through to both of those. So I have 576 kW minus kW cubed. Does that look right to everybody? And what do I have to do if I want to maximize this? Take the derivative. So I take the derivative, and when I take the derivative of, isn't k a number? So this is all a number here, times w. What do I get? 576k. Good. And then back here I take the derivative. Again, this is just a number, so I pull the 3 down, and I multiply it by the k, that number there, and then I'm w to the second, right? And what do I do with this now? Set it equal to 0. So this equals 0. I'm going to go ahead and factor a k out of both of those. And I'm left with 576 minus 3w squared.
You divide the k over?
Yeah, the k can't be 0, right? So I can just get rid of that. So just go ahead and set this equal to 0, and then you can solve for your w. And you want the dimension, so once you have w, you have to plug it back in to find your h. Okay, I'll let you guys finish that one.